Let's do the second question, which says, find the greatest value of modulus z for points in this region. Can I ask you a question? You are not going to let me down. What is z? Z is measured from what to what? We know z1, right? Z1 is from the 0, 0 to the new center. This is z1. What did we say z is? I know somebody is answering me somewhere. This is our point Q, the new center, and we said this is going to be our z1, right? Which we already made. What about z? So that we can talk about the modulus, because they want the greatest value for the modulus of z. What about z? Z is from what? Z is from the 0, 0 to the any point on the circumference. So z is measured from here to the circumference of your circle. Now, can I ask you, which part on the circumference do you see being furthest from 0, 0? Because z is measured from 0, 0. I can see maybe to go from here to there. This is quite long. Or also to go from here to what? Maybe to here. This is quite long as well. And from here to here, I don't know which one. All these are z's. All of them are z because they are from the origin to the circumference. All these are z. Which one is the greatest? Which one is the greatest here? So the correct one could have been this one, right? The greatest value of modulus z. It could have been this one. But I want you to see the keyword here. In this region. So it changes the greatest value for z. The furthest we can go, no, I'm going to remove these ones. The furthest we can go and still get into this region will have to be here. This is going to be the furthest, right? Because if I go into this region like this, somewhere here, it's still a z if I get to the circumference, right? If I get to the circumference. But then I can't, it's not the longest. If I go here, it is not the longest. So the longest has to be probably when the line and the circumference are meeting. So it's going to be here. This is the furthest, right? Where the line and the circumference meet. Remember, what is this line called? This is just like we had our line y equal to something. In here, it'll be the imaginary of z is equal to -1. This is that point, okay? Now, what we're going to do is we are going to say, okay, no problem. So this is the greatest value of my z, and they want me to find the modulus, the length of this line. They want me to find the length of this line. And I can find the length of this line using Pythagoras theorem. Right. I can find it to go down here, and I can find this length here. Right. But I need to know, for me to know, you see, it's easy. How do I know this distance here in the imaginary, and how do I know this distance here in the real, like it was in the x? I need to know the coordinates of this point. Let's call it point K. I need to know the coordinates of this point K, and because it's coming from 0, 0, its coordinates will be the distances we need, and we're just going to find their modulus. We're going to just say, we say the x we squared plus the y we squared, then we say square root of that. We are going to find the modulus of z. So what we need is the coordinates. Find the coordinates. Now you say to me, how do I find these coordinates? The only way to find these coordinates is to equate the two equations. You say two equations? Which ones? We go back to coordinate geometry. In coordinate geometry, right? What did we have? Let's kill it. In coordinate geometry, we had the equation being x minus a all squared plus y minus b all squared being equal to r squared, right? Now, remember that we have a and b being the coordinates of the what? Of the center. So a and b are the coordinates of the center. So we want to equate the equation of the circle to the equation of the line, so we get the point where they meet. Because the point where they meet is where the two equations are equal. So if this now becomes a line, and if we change this to be now a y-axis, so what we do is, this is how easy it is. We ignore this as an imaginary, we change it to be y. We ignore this as the real, we change it to be x. So it's no longer an Argand diagram, it's now a Cartesian plane. Now we say, let's write the equation of this circle. Then we'll make it equal to the equation of the line. The equation of the line is y equal to -1. Then the equation of the circle is y minus. What are the coordinates? The coordinates are minus 2 in the x and 1 in the y. So it is y minus, remember, let's start with x. It is x minus a, so it is x minus negative 2. So it's x minus negative 2 all squared plus y minus b, which is y minus 1 all squared. This is equal to r squared. It's equal to 3 squared. We make these two things equal, we'll be done. So let's go and do it. That's what we're going to do. So I'm going to say I would find the coordinates of the point of intersection. Once I find those coordinates, I'm going to find the modulus of that, which is going to be, you square root them. You square them and you square root, you have the length. So I'm going to say x minus a all squared plus y minus b all squared is equal to r squared. Now, what is your set? AB is going to be what? The coordinates. What is it going to be? The coordinates are going to be negative 2, 1. You're allowed to, okay? You are allowed to. Don't say, but we're in complex numbers. Yes, you are allowed to do this because it's the point where the two equations meet. And for the equations, we will use coordinate geometry because you want to make real equations to make them equal. So I'm going to say this goes to be x minus, my a is a negative 2. So x minus negative 2. And I will square that. Plus y minus b, which is y minus 1 squared, is equal to r squared, which is 3 squared. Can you see this, class? Now, minus negative 2 becomes plus. So it becomes x plus 2 all squared plus y minus 1 all squared is equal to 9. This is going to be what I have. Fine? Good. Now, for the other one, we have y being equal to, this is for the circle, okay? So you can say this is for equation of the circle, okay? Then you can now say for equation, you can be speaking, you can be communicating of the line. You'd now say here y is equal to negative 1. So now you're going to say x plus 2 all squared plus, instead of y, we are putting, so you're going to say plus y minus 1 all squared. This is equal to 9. Then you say let y be equal to negative 1. Becomes x plus 2 all squared plus minus 1 all squared is equal to 9. What would we have here? Minus 1, it will be now x plus 2 all squared. What we'll be getting is just something quadratic, right? Which we can just solve fast. We would say x plus 2, here's how I'm going to solve it fast, all squared, plus, this is negative 1, negative 1 minus 1 becomes negative 2, all squared becomes 4. This is equal to 9. So I can say x plus 2 all squared is equal to 9 minus 4, which will lead me to have, I'm coming here now, to say x plus 2 all squared is equal to 9 minus 5 is 9 minus 4 rather. 9 minus 4. This is going to be equal to 5, which means x plus 2 is the square root of 5, right? You can say plus or minus root 5, which means x is equal to, this plus 2 goes to the other side, becomes minus 2 plus or minus the square root of 5. Isn't it? Now, let's get a solution for our x. We would have x being equal to, which one is realistic here, right? If we come here to look where they are meeting, they are obviously meeting here when it's negative. So we are obviously going to get the negative version of x. Which one would it be? Minus 2 minus root 5, because minus 2 plus root 5 will probably give us a positive. Let's try. If we say minus 2 plus root 5, we would get a positive answer. So it's not the one. But if we say minus 2 minus root 5, this is going to be the one we want. So here we can say x is equal to minus 2 minus root 5, right? This is the point where they are meeting. Then y will be equal to what? What will be our y? Where they are meeting, y is equal to negative 1. So x is equal to this, and we saw that y is equal to negative 1. So now we are just going to say modulus z. Z modulus is going to be square root of minus 2 minus root 5 all squared plus negative 1 all squared. It's x squared plus y squared. Then you get their square root. this will give you the modulus of z. What is this going to be equal to? So I'm just going to say square root sign. Inside I open bracket, I say minus 2 minus root 5, close bracket, squared. Oh my gosh. Minus 2 minus root 5, close bracket. Okay. I close the bracket, then I square, then I say plus, I say 1 squared. Let's just say, or negative 1 squared if you want to put it. Still the same. We know that when we square, everything becomes positive. What do we get here? Modulus of z is 4.35. So the greatest value of modulus of z is 4.35. So don't ever be confused by greatest value. Greatest value of modulus of z, we are just looking for the furthest point. That's what it's saying. What is the furthest point from the origin? Okay, they want the furthest point from the origin. So you have to identify it. Here they want it in the shaded region. The furthest point was here. Okay, which part of this region? This was the furthest point, so we just need to find its length. How? First find its coordinates, and it's where the line and the circle meet. And we had to convert the equation of a circle, the one we did in coordinate geometry, and we made it equal to, this is the equation of the line, then we made them equal to each other. We said let y be minus 1 in the equation of the circle. Then we solved. When we solved, we got the coordinates. Y was equal to minus 1. We knew it already. Then we found the x coordinate. Then we threw them in to find the modulus of z. And we are done. This would be your solution. And you are done. Done. This is all. Now we're going to see questions that will ask us for other things. Like in loci, if we made a question which asks us for a part line, we need to look for it. And also a question which asks us for perpendicular bisector, and we see what to do. And we also want now a question which is going to ask us to find the roots from complex numbers. Let's see how we're going to do it. Goodbye for now.